video is Unit 1, learning targets 10 through 17, Science and Practice. In this video, we'll be looking at the three major assumptions in science. In science, there are three basic assumptions on how scientists do their work. Here's lightning. Maybe 1,000 years ago, when someone saw lightning, they thought, well, what could it be? Perhaps the gods are angry at us and they're trying to kill us by crafting weapons and tossing them at us. Well, now we know that it's just a static electricity thing. And when positives and negatives meet up, they connect and pow, there's a nice big spark or something along those lines. And so the assumption in science, first of all, is that there are natural causes for natural phenomena. Natural causes for natural phenomena. Anything in nature can be explained by natural causes. This is as opposed to supernatural causes. Science's job is to answer questions concerning nature using nature. And so, for instance, we look at this picture here of this. This is an underwater thing. And perhaps if you were part of this starfish colony and you saw the big water tornado, this is actually underwater. Doesn't look like it. Maybe it looks like it should be on the ground except for all the starfish. But this is underwater, and you would think, well, maybe the gods are angry and they're spilling down ice tornadoes on us. Well, actually, this just has to do with an effect where the water gets more dense up here at the top, and it's super cold, and so it eventually, because of its density, goes to the bottom in a swirl here, and as soon as it hits something, it instantaneously freezes, and thus causing a calamity among the starfish population. It's a natural explanation for a natural phenomenon. Next is that based on these natural phenomena, evidence can be gathered and experimentation can be performed. We can gather evidence, we can perform experiments based on nature. Nature can be observed, data can be collected, questions concerning nature can be answered using experiments. You see this is a volcano, and you see the lightning coming out of the volcano, and it looks kind of crazy, and there may even be some sort of weird entity, kind of forming here, who knows what. But it's a natural thing. Because of all the electricity in the volcano, it causes lightning sometimes. Scientists can gather information. They can do experiments in order to find out these sorts of truths. And then lastly, the third major assumption is that nature is ordered and consistent. Nature is ordered and consistent. Nature has order to it and works in a particular way that can be predicted. Here is the man that discovered gravity long ago, Sir Isaac Newton, and he was proving to this crowd here that that these two objects, even though they're different size, would fall at the same rate because gravity is a constant thing, and they couldn't believe him. They're kind of shell-shocked like this guy back here is. All right, and so he was right. And when the first astronauts went to the moon, the very first thing they did is they got a bowling ball and a feather, and they dropped them at the same time, and lo and behold, Newton was right. Why? Because nature is ordered. Nature is consistent. And because it's ordered and because it's consistent, we can make predictions based on that. If gravity always works the same way, then I trust that I can use that same way when making predictions. What is a prediction? Well, it's just a guess based on what you already know. And so here's a picture of something. It's obviously nature. It's the ocean, and there's some trees, and perhaps the sunset in the background, and the stars. And your first thought is, oh, what is it? Is it an underwater colony of sea monkeys that are lighting up the world? Perhaps they're attacking. We should be concerned. No, it's just phosphorescent algae, because it's a natural thing that can be explained with the natural phenomena. It can be explained using experimentation. It can be explained because nature is ordered and nature is consistent. Well, based on these assumptions, scientists do experimentation often, and they publish their work in something called scientific journals. Scientific journals aren't like a magazine you get off the shelf. They're pretty dense reading and they're pretty complicated. But for scientists, this is where they publish their work. And some of them, it takes years and years and years to finish these experiments, and they publish this work. But before they can publish it, not just anybody can go to an experiment and publish to these journals. There's a process called peer review. Now, peer review, this shows a man that's about to go through the gauntlet of axes and clubs and chainsaws and grim reapers and a dude with a shotgun before his paper is going to be accepted. It's not quite like that. Scientists can take a paper and they can read it and they can make sure they can test to see if there's any bias in that paper. What is bias? Well, bias is a particular bent or showing favor for or against something. If a scientist shows bias in his experimentation, then perhaps he's going to make his data say what he wants it to say based versus saying what it actually said. If a scientist wants to prove something right, well, maybe he'll make the data say that, which is a biased thing. There are different kinds of bias. There's unintentional bias. For instance, people used to believe the world was flat. They were very biased towards that opinion. Columbus wanted to sail the ocean blue. Well, they were against it because they thought that he might fall off the edge into the mouths of beasts. It wasn't that they knew the answer and were preventing him from learning the truth. They just didn't know, but they were still biased toward their opinion. That's unintentional bias. Versus intentional bias. Now, you guys don't know who, you might know who this is. It's O.J. Simpson. So O.J. Simpson was charged with murder when I was in high school, and the Newsweek article there posted his actual mugshot. Well, the Time magazine article posted a mugshot that was much darker and brooding. Why? Because they're biased. This is intentional. They wanted to paint a picture of OJ as being a dark and sinister person, and so they put that picture on there of him, and it worked. Right? Whether he was guilty or innocent, it's whatever. You can have your own opinions on that. But based on that Time magazine cover, many people thought, well, he's a crazy psycho. Well, maybe, maybe not. But we can't base that off the bias that we're shown. We have to do real experimentation. Now, one of the ways that scientists um, prevent bias is something called blind trials. Now, blind trials, when information is concealed from the scientists or from the subject or from both in order to prevent bias. So here's an example. A scientist comes up with a medicine that he believes cures a particular kind of cancer. Well, he might have 100 patients come in that have this particular kind of cancer and give 50 of them the cure and give 50 of them what's called a placebo, which is just a fake drug or a fake cure. And the subjects won't know whether or not they've gotten the cure or the placebo. Why? Well, any possible side effects, anything that could happen based on this medicine, he wants to know. So in order to judge it fairly, but if the people knew, well, I know that I've got the cure, or I know that I'm taking some kind of weird medicine, then they're more likely to act strange about it. Sometimes that information is hidden from both the scientist and the subject until the end, and that's called a double-blind trial. Now, how does this apply in the real world? Well, in the real world, there are trials and experimentations and lots of things done. I use a picture of a cotton field because cotton fields and cotton farmers are near and dear to my heart. Most of my family is in cotton one way or another. And so in agriculture, This experimentation and these types of scientific assumptions are used all the time in order to make better pesticides, in order to make better herbicides, in order to make crops grow better. And science works to help those crops and to help the farmers make a better product. Now, let's talk about some terms. Theory is the one of the most um, incorrectly used words in science. We typically use the word theory in our common vernacular to talk about a guess. Well, in science, a theory is a well-tested explanation that unifies a broad range of observations and questions. All right, put that in layman's terms. A theory explains a phenomenon based on experimentation, based on observations. For instance, this is a picture of Darwin's finches. One of the criticism that's often thrown at evolution is that it's quote unquote just a theory. Well, in science, the word theory actually carries a whole lot of weight because theory in this case means that it is an explanation of all the evidence that's been gathered over time, of all the observations that have been made, and based on all of that, this is the explanation for what science has for how life changes over time. It's not simply a guess. Now, can a theory change? Absolutely. A theory can change. It can be added to, it can be taken away from. When Darwin first wrote his book, evolution was essentially just natural selection, modification over time. Well, now we know about things called genes and chromosomes and all of this kind of thing, and we've added a lot to that theory of evolution, but basically the same idea is the same. Populations change over time. That is the theory of evolution. It's the same thing with the germ theory of disease. How do we explain disease? Well, there's bacteria, there's viruses. That's how we explain it. Are we still learning lots of things about disease? Yes. And so the theory is being added to. It's not a guess. It is an explanation. Theory is, if you had to use one word to define theory, you would use the word explanation. Then there are laws. Now, a theory doesn't eventually become a law when it like graduates, and that's not how science works. A law is a description of how nature works. The law of gravity, for instance, describes how nature works. It describes this force of how things are pulled towards the center of the earth. It is a law. You can't get around it. If you jump off the desk, you will land on the ground because of gravity. All right? What goes up must come down. That is the law of gravity. All right? We'll talk about several laws in science. These are laws that govern how science works. It's different than a theory. And then there are facts. What is a fact? A fact is just information that is observable. The sloth has moss on it. The sloth's face is funny. The sloth is looking at me weird. It's in a tree. These are all facts. The sloth eats leaves. The sloth is slow. Birds lay eggs. The bear is brown. So forth. These are facts. It's different than a law. The bear is brown does not govern how science works, nor is it an explanation about bears. It's just a fact about bears. Now, let's use this picture to talk about theories and facts and laws and how they can all work together. Well, here's a roller coaster. If you've been on a roller coaster, they're fun. They get less fun as you get older. Well, the law of gravity states that there's an attraction between any two objects in the universe determined by their mass and distance apart. In fact, so gravity states, which I just gave you the scientific definition of gravity, gravity states that this roller coaster will go down. It just will. It's going to go towards the Earth because of the attraction between the Earth and that roller coaster. Well, a fact about gravity is that that force acts on an object at 9.8 meters per second. And so that roller coaster will travel down at that speed. That is a fact about gravity. There are several theories about how gravity actually works. Is it a force? Is it a wave? Is gravity a particle? There are lots of theories about how gravity works. And so we'll use those words interchangeably, but particularly focusing on theory. I don't want you to get it mixed up with a hypothesis, because a hypothesis is a guess based on a question. Okay? Even a even an experiment or even a question done or asked concerning, for instance, evolution or germ theory or all these things can have a hypothesis associated with it. And so I don't want you to get those two things mixed up. A hypothesis is just a guess based on observations, based on a question. A theory unifies a broad range of these observations and a broad range of questions and experiments and all these things and explains a particular concept in order to put it all together. And theory is an explanation. A hypothesis is just a guess.